In this video, we will learn the mathematical notation for recursive formulas. In a previous video, we saw this example. We wanted to generate the first three terms of a sequence whose first term was 5 and whose nth term could be found by adding 3 to the previous term. Let's take a look at how we could generate a mathematical definition of this sequence. We did see in the previous video that usually when we write a recursive formula for a sequence, we'll begin with a brace like this, because any recursive formula requires at least two parts. First, we need to define the first term or first terms. Then we need to tell how to find each successive term after that. We need to tell how to find the nth term, and that rule will be based on one or more previous terms. So here, this part right here, telling us that the first term is 5, translates to the very first part of the definition of the recursive formula's definition. The first term is 5. We always generate or notate the first term as a sub 1. A sub 1 equals 5. Now, we want to be able to generate the nth term. We know that the nth term can be found by adding 3 to the previous term. And here's where the notation is going to get a little bit more technical, but this is certainly very doable and very understandable if you understand what the subscripts of each term represent. The nth term is what we're trying to generate. Remember that the subscript tells you which term that we're looking at. So a sub 1 tells us that we're looking at the first term. A sub 2 would tell us we're looking at the second term. Well, if we're looking at the nth term, what we'll be looking at is a sub n. The nth term can be found by adding 3 to the previous term. Now in the previous video, we did this. We said we would take the previous term and simply add 3. Now this previous term part is what's going to change. We're going to have a little bit more of a mathematical way to write this. So let's get rid of this, because we don't want to just talk about previous terms like this. Let's think about how we could write the previous term. If the term that we're trying to generate is the nth term, which term would come before that? To help us answer that question, let's think of a simpler question. This is a great mathematical strategy for trying to simplify any problem. If you're talking about a problem that involves variables, pick an example where you would actually have numbers and try to answer the question with the number and see if that helps you answer the question with the variable. It goes like this. Let's actually pick a number for n. Let's say we're trying to generate the 11th term. What we need to do is use the term that comes before the 11th term. Well, which term comes before the 11th term? If a sub n equals 11, the previous term would be a sub 10. So we took 11th term down to the 10th term. Now if we're dealing with, say, the 23rd term, if we're dealing with a sub 23, then the previous term, what would it be? The term that comes before the 23rd term is the 22nd term. So here, when n was 11, when the term that we're generating was the 11th term, the term before was 1 less than that, a sub 10. So we can generalize this. If we're looking for the nth term, then the previous term is simply 1 less than the term that we're on, which we can note by n minus 1. This means that we're looking here at the nth term, and this a sub n minus 1 means that we're looking at the term that comes before. Now it's very important to note that this minus 1 is still in the subscript. This does not mean that we're subtracting 1 from the term. It simply means we're looking at the term that came before. So we can apply this logic to our recursive definition. A sub n can be found by taking the previous term. Well, what term came before a sub n? That would be a sub n minus 1. And then we add 3 to it. This is the notation that you will want to use when you're generating these recursive formulas. Now, we already generated the first 3 terms in a previous video, but just so that you can get used to how this looks, let's go ahead and do this again here. We want to generate the first term, the second term, and the third term. The first term is always given to us. The first part tells us that a sub 1 is 5. To find a sub 2, I'm going to take a sub n minus 1 and again that minus 1 is in the subscript, and I'm going to add 3. Now, n is the term number that you're on, so n is 2 here. So a sub 2 equals a sub, since n is 2, it's 2 minus 1 plus 3. A sub 2 equals 2 minus 1 is 1, so this is a sub 1 plus 3. And now we should look for a sub 1. A sub 1 is 5, so I can substitute. A sub 2 equals a sub 1, which is 5, plus 3. And 5 plus 3 is 8, so a sub 2 equals 8. Now, as you get good at this, you won't need to write all of these steps here. You should be able to skip at least a couple of those steps and become a little bit more efficient with this. But I just wanted to show you the entire detail of what's going on here and why that a sub n minus 1 actually works. Because what it does is takes the n value, the term number we're on, and simply takes 1 away from it. So if we're on the second term, it takes us to the first term, which is exactly what we want, because the first term is what comes before the second term. So let's do the exact same thing with a sub 3. The formula tells us that the nth term, so in this case the third term, can be found by taking a sub n minus 1, the previous term in other words, and adding 3 to it. A sub 3 equals. Now once you start to understand that this just means the previous term, you don't have to put this step in there anymore. You just know that this means it's the term before the third term, which is the second term, and we'll add 3 to it. We want to know what the second term is so we can substitute. The second term, we already found it, is 8. So I can substitute in 8 and add 3. So a sub 3 equals 8 plus 3, which is 11. So here are the first 3 terms of this sequence. And these should be the exact same 3 terms that we found in the previous video. So the only change here is that instead of just using the previous term notation, we're going to use a sub n minus 1 instead of using the words previous term.